Hi, and welcome to tonight's webinar. My name is Catalin Dumitras, and I'll be your host this evening, where the topic is how to up your microservices game when you're using PHP with AWS. So, a few words about me. I'm the principal cloud architect here at Pentalog and the cloud department, as we call it, customer DevOps, where we help our clients find the best technical solutions for them. I also run the cloud mentoring program for developers and DevOps engineers so they gain new cloud skills. And without further ado, I'd like to start with the contents of tonight's webinar so you can get a clear expectation. All right, let me share my screen. By the way, there will be a full Q&A session at the end. Please use the Zoom Q&A section and ask your questions as we go along. If there's any time to wait when something is deploying or something is doing whatever we have to wait, we'll be answering those as well. All right, so first we're going to start with why the cloud or why AWS. Most of you might be accustomed to AWS or Azure or none. So we want to make an even playing field and have the same understanding about what we're going to be talking about this evening. Then we're going to dive into infrastructure as code. Don't worry if you don't know what that is. We'll explain it immediately. We'll explain the architecture for tonight's, let's say, proof of concept in PHP. And we're going to go through all of the steps we advertised that we're going to go through. Setting up a Docker cluster, auto-scaling the cluster, adding an application load balancer, doing a CI/CD pipeline for our services, and of course, a small introduction into debugging. At the end, as I stated, the Q&A section. All right, so why the cloud? Well, long story short, it allows us to deliver more, faster, and of course, focus on what matters. As developers, we really don't have a need to know if that server is, let's just say, failing due to old hardware, or is it really something that we should be handling that some hard drive is filling up somewhere? That really shouldn't be our focus. We should be probably focusing on what our features, what our clients want as features, right? So how can we use the best new architectures, domain-driven stuff? How can we implement the latest frameworks, the latest migrations for Symfony, for Zen, for whatever we want to use, or maybe even branch out into new programming languages. Maybe worrying about old failing hardware is not on our priority list. So how exactly does the cloud allow us to deliver more and faster and to focus on our application code? Well, it abstracts and it automates. Well, these concepts should be very familiar for us as developers because that's what we do writing code every day. We abstract, we create a humongous class, well, hopefully not that humongous. Well, we do all kinds of logic and then we abstract it with a few public functions, right? Or maybe some interfaces for those functions. And it allows us to reuse stuff and to build more complex systems easier. That's why we use frameworks. That's why we try to abstract as much as possible, because those high quality components really allow us to have a greater velocity. And this is the approach AWS has done, and hopefully other cloud providers have taken this to heart. You take something that nobody really cares about, and you abstract it. You make it a commodity. You make a hard drive or a server very easy to get. You don't go through a bunch of management requests and tickets in Jira or whatever it is to create a new server. You just go somewhere on a dashboard and push a button. Or better yet, you use infrastructure as code. And what you don't abstract, you automate, right? Whatever you can't really abstract away from, you automate so it becomes, again, mundane and available at the push of a button or some other stuff that's similar to that. So a few options in the cloud. Here we have the four major options, starting from what we're accustomed to, the on-premise environment, the one in a closet somewhere inside the office, or a data center, a classic data center, up to today's most recent developments in serverless. So as you can see on the left, we basically have to manage everything ourselves, from the network, the hardware, up to the application code. This is quite a lot to do, and maybe not the most interesting of things for us. The next runner is infrastructure as a service, where the cloud providers have abstracted storage, hardware, network, and we care about everything from the operating system above. This was actually covered in the the earlier webinar, where we focused on Java and Elasticsearch, Elastic Beanstalk. The next option is platform as a service. Platform as a service, or maybe you can even go as far as maybe comparing it with container as a service, is something that we only care about the runtime and our own application, and the cloud provider takes care of the rest. And of course, serverless, where we only care about the application code. Small downside to serverless is that we have to think in novel ways. We have to implement new architecture paradigms. And usually that means quite a bit of refactoring in our own applications. So it makes less sense when you're starting with the cloud, because it is more advanced, but the advantages are well worth it. So what we're going to be talking about today is more or less a combination between infrastructure as a service and platform as a service, and see how to get started with that for your PHP microservices. But why should we choose AWS? So of course, we hopefully agree on using a cloud provider, because it's going to help us a lot. But why should we choose AWS? Well, let's take a look at this Gartner quadrant, updated for 2019. Gartner, of course, are a very famous company which have these analysis about all of the providers and suppliers on the market for different type of solutions. And this is for infrastructure as a service. Amazon, or Amazon Web Services, is the first in the pack. And this is not a new thing. They have been, this is the 9th continuous year that they're on top. So they must be doing something right. But what really gets my interest is their pace of innovation. This was screenshotted from a conference this year called AWS Innovate, where in a presentation they showed how many features they deployed to their cloud year on year. And if you can we see a constant growth, and the numbers for 2018 are really impressive, almost 2,000 features. Now, I have no idea how the number is going to fare up for 2019, but I hope it's much larger than 2,000. All right, so that's why we'd like to choose AWS. It is the biggest cloud provider, the most mature, the most features, and of course, since they have been in the industry so long, there's a plethora of options when it comes to learning, courses, books, video series, basically resources. The resourcing community for AWS is bigger than any other cloud provider. So more features, more support. I guess that's where we're going to get our best experience. Let's start talking about infrastructure as code, because last time we provisioned everything with the browser, basically the console, which is not bad, but it's definitely not great. By today's standards, we would really want to use more advanced techniques like infrastructure as code. So just to better understand what infrastructure as code is, we have this definition over here, and it states that it's the idea that systems and devices, basically all kinds of hardware, that we traditionally use as infrastructure for running software is treated as if they were software themselves. So we're able to put in to get a representation of our infrastructure and pass it through all the normal processes in the software development lifecycle. So that means peer review, of course, pull request, emerging strategy. We can always roll back to a state previously that we know it was working, or We can always study the changes, doing like a git log or git blame. But this is a very powerful concept, and we're not just going to be talking about it tonight, we're also going to be showing you a demo. So let's start with the first version of infrastructure as code in AWS. I'm going to focus on the AWS ecosystem and not go into other open source competitors to or alternatives to these services right now. We're trying to keep this webinar short. Well, shorter than the last one anyway, which was almost 2 hours. So, CloudFormation. It started in 2010. So they first launched it as the ability to use JSON, let's say models, basically templates, to describe your desired infrastructure, and you would then submit these templates, which have their own structure and definitions, to the CloudFormation service. So it comes in 2 parts. It's the definitions and, of course, their service. And what makes them stand out against the community or alternatives is that you tell them what you want to have, and they take those templates and handle all the state and rollback procedures for you. In other community options, you have to manage a file, be careful not to lose it or corrupt it or stuff like that. In here, you actually have to just supply these templates and maybe some parameters. All right, this might not be the best option when you have a big infrastructure. So JSON is nice. We all moved from XML to JSON for various reasons, but it's not the most appropriate thing to manage your infrastructure in, because if you have like 20, 40, 70 resources, those JSON templates are going to get really, really big. And it's not a lot of fun managing 4,000 lines of JSON in a file. So fast forward to 2016, they released what I call the version 1.1. So basically, they added YAML support, and this improved the experience quite by a large margin, because the templates become more readable. They added some shorthand formats for some functions, and honestly, it's just wonderful not to see all those curly braces. So kudos for that. Let's talk about the option for infrastructure as code when it comes to serverless. Just touch upon it a little bit. We're not going to be using it. I just want to give you the full backstory. So a bit later in 2016, serverless application model was launched, and it's basically something to help you write serverless functions more easily, because usually you would have had to write, let's say, a lot of lines to get a serverless function going. So these are 28 lines, let's say 27 without the first one. After SAM was introduced, this turned into 8. So definitely a much better experience for the serverless developers out there. And for you thinking what does serverless have to do with PHP, well, you can actually build PHP apps that are serverless now, and it's fairly easy, much easier than it was a year ago. All right, so they add some more features for serverless, like local debugging, but the most interesting one is transforms. So transforms is basically a macro, something that takes your template, finds certain types of resources and expands them, right? And this has a lot of relevance for what we're going to be doing tonight, because that idea, coupled with the use of a real programming language, is what led to the development of CDK, which stands for Cloud Development Kit. So as I said, Cloud Development Kit was launched in 2019, just a few months ago, generally available. The beta has been around a bit longer. And it's quite an improvement. You can use a real programming language, TypeScript, Python, C#, to actually, no PHP yet, sorry, to get your infrastructure defined in a much simpler way. So as you can see, from 8 lines of code, we can now define a Lambda function in 1. Granted, It's not going to pass any code sniffers because it's a really, really long line. But I just wanted to show that now it's possible. All right, so how does CDK work? Well, CDK isn't declarative anymore. So, right, you don't say exactly the structure when you want, how you want it to be. It's no longer a template. You actually have the power of using classes and abstraction to a much greater degree. And there are three, let's say, terminologies that you have to be aware. So app is basically a CDK app. It is the root container for everything, much like your, let's say, Symfony app would be. You have your stacks, which relate one-to-one to the CloudFormation stacks. CDK, you actually just basically takes your code and compiles it down to CloudFormation, which it then deploys for you. So it abstracts again on the abstractions from AWS. All right, so the stacks are one-to-one, and now we get into constructs. Constructs are basically our framework components, let's say, and they come in three flavors. Level one, which is automatically generated from the reference from CloudFormation, basically what type of resources you can deploy in the cloud. Level two, which AWS comes and takes all these services, a bunch of services, maybe groups them together, adds some functionalities. Let's say you'd be using those quite commonly together. They help you out by adding some sane defaults, some good best practices in relation to security and so forth. And level three, and the most interesting and important of all, is our components. Because right now, our infrastructure is not treated as code, as a template. It is code, right? There are classes. We can use object-oriented programming, and we can abstract, and we use a lot of stuff. So this is something I'm really excited about, and we're going to be showing some of the code we've been using to build a demo for tonight. All right. Since we've been talking about the demo, let's take a look at our architecture. So on this diagram, we have people. We have people coming into a load balancer. Now, this isn't any normal load balancer. It's an application load balancer, and we're going to cover it in a bit in more detail once we get to that section. Our load balancer sits in a region, an AWS region. So basically that would be something like Ireland or Germany, or they have different codes, but that's the geographical region. And we would have two availability zones as a start to have it highly available. An availability zone in AWS is a group of data centers closely together, which basically might have the same internet connection, or they're so close together that they might be all cut off from the internet at a certain point in case of a natural disaster. But availability zones are completely separated in every way in relation to hardware, power, internet, and so forth between each other. And AWS regions are so separated from each other that you could consider them different clouds. And in these availability zones, we have public subnets and private subnets. Well, public subnets is stuff that is available, reachable from the internet. And we only have our load balancer and the NAT gateways which allow us to have connectivity going from our private networks to the internet in case we need to make some calls, which we do today. And that's their only purpose. They are not reachable from basically you can't SSH into them or anything like that. And inside those private subnets, we have an autoscaling group, which we're going to be talking about shortly, filled with our virtual machines which run our Docker container. Our Docker images come from a CI/CD pipeline, and that CI/CD pipeline code commit is not the right. No, I've mistakenly added that name there. It's actually ECR. So what basically happens is we'll have a git push into a Git repository. We'll have our build, and after we have our build, we're going to push to our image repository, an ECR, and that activates another pipeline which will deploy to our services here. And everything related to monitoring, or let's say observability, which is a more fancy and more complete term for a lot of practices used today, is going to be in CloudWatch. All right. So let's talk about our Docker cluster. There are two options actually the three options to run Docker inside AWS. Okay, four. Let's say four. The first one is the option which I beg you not to use, is running your own virtual machines and just installing something there like Docker Compose or Kubernetes yourself, just managing everything. Please don't do that. There's not a lot of value in using the cloud that way. Second option, you just have some Docker files that you'll be putting into Elastic Beanstalk. Again, not the most fancy option, but it will get you out there. You can use it. The third option is Kubernetes as a service. So that is EKS, Elastic Kubernetes Service, which AWS manages the master for you and some other things, and you worry about all the other instances besides the master. But they do manage a lot of the stuff for you. And the last option that we're going to be talking about tonight, which is my favorite, ECS, Elastic Container Service, is their native service. All right, so we're going to be doing two things. We're first going to be looking at the code, the infrastructure as code, and then we're going to be looking into the AWS console to look at what it has provisioned. Mind you, I have already provisioned most of the stacks because each stack takes about 5 minutes to provision, and I didn't want to make you wait. All right, so without further ado, let's open the editor. If you notice the files here on the left, this was started as a sample project from CDK on the TypeScript platform. TypeScript is the most easiest platform to start on today because they have the most examples. CDK itself is written in TypeScript, and of course, since we're, let's say, PHP developers, but most likely you are a full stack developer, you also work with front-end applications, more or less. So TypeScript, TypeScript, JavaScript, it's going to be a lot more, let's say, up your alley than something like Python or C#. So TypeScript that is. Let's take a small look at our folder structure in here. We have the bin, where we have a demo.ts file. This is our entry point. We have cdk.out. These are all the JSON templates which are generated, the CloudFormation templates which are generated for you. Our library folder, which we're going to look at in a short while. Our microservices folder, we're going to be looking at 3 microservices today. And then we have a bunch of configuration files. So let's look at our entry point over here. This is your infrastructure today, how you would actually define it. Let's go into presentation view. Please remember to ask any questions you might have on the Zoom tool. We will take questions shortly. So since we're using a programming language, you are free to structure your infrastructure as you wish. I chose to make some base infrastructure stacks for two environments, one test, one production. I have a bunch of, let's say, infrastructure parameters, or let's say data that I want to pass from one stack to the other. And this is what I built in the properties object over here. And then I use it to start the front microservices stack, the backend, basically two backend, the backend 1 and backend 2, with just a few changes, right? So Let's look into the base stack, because this is something we're going to be interested about when we're talking about our ECS cluster. We have a bunch of imports, as you naturally do, right? We have an interface, and we have our base stack. This is where it gets interesting for us. So we start by building a VPC. VPC stands for Virtual Private Cloud. It's basically our namespace in the cloud. It's our logical separation between everything else in our account. It's always good practice to have separate VPCs for separate stuff. Like, for example, if we had two different environments, we would create one VPC for each environment. And on some projects, we go even further. We create a separate AWS account for each environment to make sure that everybody's comfortable and developers can change whatever they want without being at risk of doing something weird in production. So once we got our namespace going for us, we'll create an ECS cluster, which is really simple to do. We just instantiate a new ECS cluster, and we give it as a parameter in the VPC. So that's fairly interesting, and it's extremely simple. Now, there's not going to be a lot to do with our cluster unless we add some instances to it. So what we're going to do is, by default, configure our autoscaling group to add some instances. And for this demo, I chose T2 large because they're relatively cheap and have a lot of memory to them. So I chose them, and I set up a desired capacity of 4. So that means there are 4 servers in each cluster. If we take a look further down, we also added some more permissions. So please take note of the SSM manage instance core over here. This is going to be very relevant soon. When we get into the debugging, we basically installed the SSM agent and we started, and we're actually going past our ECS cluster scope. We're going into the auto-scaling itself. We want our cluster to scale up and down based on CPU. In this demo, we don't have a benchmarking exercise where we actually simulate a lot of synthetic load on the CPU to show the scaling up and down. But this is how you set it up in the real world. You would say that I would like to have a target utilization of 80% on the CPU. And based on your min and max capacity over here, AWS will monitor your instances and say, on average, all your instances are at 20% or 30%. You obviously don't need to pay for all those servers. So let me shut down one of those for you, and we'll see how your load reacts. And this is completely elastic. If, for example, you have one server right now, but you have a rush hour type of thing, or people entering on a sale in your application to buy things, based on the CPU, it will scale up. So that's a very nice thing to do, and it's so easy to set up. A few lines of code. All right. Having this auto-scaling group is not going to be a lot of, it's not going to be very practical if your instances come and go, but your clients never reach them, right? So the way you would do this is by using a load balancer. And we're not using a classic load balancer in this example, we're using an application load balancer. And we'll show you in the console the differences and why this is a much better option today. To create a load balancer, we only have to instantiate a new class, and we add a listener. It's very important because you could have a load balancer listening on multiple ports. That's why they're separated, the listener and the load balancer. So you could listen on port 80 and port 443 for each TPS, and redirect your users when they come into the insecure port to the secure port. And you can do this fairly easily. Now I added an extra firewall rule over here to allow basically egress. That means traffic from the load balancer anywhere else. And let's not go too far. Let's go a bit to the console and see how this looks. Let's start with our VPC. Oops, sorry. Let me go to the VPC over here. We have three VPCs. We have our default VPC, which comes when you create your AWS account. And then you have your test and prod. If you can remember, these are the stack names we have over here. Right? Test and prod. And we have in our app, our VPC. That's its ID, right? So we have a prod base and a prod test VPC. If we go into ECS, we have clusters, right? We'll have two clusters over here. We have a test and a prod. And you can see we're running some services in the EC2 mode, not the serverless mode or the serverless container mode. For that, please stay tuned on our next webinar. We're going to be looking at serverless containers. Small spoiler, serverless containers means we don't have to manage our EC2 instances. We don't care about them anymore. So that's even better. All right, we have that. And now let's look at what I promised you, our load balancer. If we take a look into our load balancers, we can see that we have two of them, one for each environment, of course. And our load balancers have something called target groups and the rules pointing to them. In a classic load balancer, the load balancer only knows about IPs and ports. It doesn't know about what you're sending inside those TCP packets. So that's what we call a layer 4 versus a layer 7, I believe. I hope I'm not right. If I'm wrong, please correct me. Send me a message on the Q&A. And that means we are able to do a lot of routing that would not normally be available to us on a layer 4. So it's now aware of hosts and paths, and we could do something like this. We can add a path over here. Let me just add this. Insert a rule, and we could say that if the host header coming in from the request, it's something like API dot whatever or service one dot whatever, you can actually route it to a different ECS container, a different Docker container, and you can do this with a lot of stuff, right? And this is very, very powerful. That means you can have much fewer load balancers for your environments, and they can do a bunch of logic to forward to other places like containers or EC2 instances and so forth and so on. I'm not going to do anything right now. This is actually a bad practice to change stuff that you've deployed via infrastructure as code because they won't match your expected state. All right. If I click something like, you see that I have a default rule. This is required because we deploy our stack without having any service. And we have to have a default rule. But I'll go into a single target group over here, and this is actually for our front-end service. And you can see a bunch of stuff like targets. We can see it's the Docker container IP address over here. And we can have health checks. We can see some monitoring. Oh, requests, response times. This whole data over here lives in CloudWatch. And you can build your own custom dashboards with all kinds of metrics which are in AWS by default, especially if you use an application load balancer. I believe there was something like 50, I'm not sure if it was 50 metrics available on the enhanced version. We have to basically click something to enable more metrics. I hope I'm not confusing with API Gateway, but a lot of metrics available for you to figure out what's going on in your application. Okay, so that's what's a target group, and that's why we use load balancers of the application type and not the classic type. Okay, let me go back to presentation. So we covered the ECS container, cluster. We covered autoscaling. We've covered the application load balancer. And now we should talk about the CI/CD pipeline. Now, before we go into the actual code, just want to use this graphic to refresh everybody's mind about what CI/CD really means and how we can implement it in AWS, and why should we implement it that way, and why shouldn't we just spin up a Jenkins instance or use something else. All right, so continuous integration is when we push our code. After we push our code, we have a bunch of stuff in the cloud somewhere, which is running PHP unit, it's running code sniffer, mess detector, PHP stand, whatever you have over there that you'd like to run. And this is called continuous integration. Obviously, you should also run these tools locally after you finish developing your feature, but it's there as as a safety net. Make sure that everything is integrated when it should be. This also has a lot of sense when you have front-end applications which need to be minified, compiled, whatever you have, React, Angular, whatever it is. And the next step is where it gets interesting. So continuous delivery is automating that git push commit in towards production with a human approval, obviously, because that's the difference between delivery and deployment. We need to have a person that says, after testing in a test environment, multiple, is that I agree for this to go into prod. Continuous deployment, on the other hand, has no human interaction, which assumes that we have a very good set of acceptance testing. Yeah, there are not a lot of projects out there which have that high degree and confidence and quality in automated tests, but it's something we all strive to. And this allows us to have a very automated flow from development to production. How will we implement that in AWS? Obviously, we would use some services. And the services I would say are best suited is Code Pipeline as a general orchestrator and dashboard. Code Commit, which is the hosted Git platform. Now, mind you, I am not suggesting you move away from Bitbucket or GitHub or whatever you're using that you are accustomed to and you like their interface very much and you collaborate very well. The interface is decent in Code Commit, but what I would suggest you think of it as is as an entry point for your application to start the process. So you can use hooks and all kinds of features in either GitHub or other providers to push certain branches into other repos, and that's what I'm suggesting to do over here. There are other methods, but they lose a bunch of metadata when it comes into the CI/CD pipeline. If you do this, you're going to be seeing the GitHub message and the GitHub tag or SSH1 there, so you can be sure what's being run through the pipeline. Code build is your Jenkins worker or agent, whatever you want to call it, and it's just a Docker container which runs any command you would like to run, basically, to build your application, to compile it, to minify it, whatever you want to do. And it's very nice because you don't have to manage any infrastructure. And if you want, you can also bring your own container in case you have a lot of stuff to install or very custom software. When it comes to testing, you can use Code Build with or without other tools to run acceptance testing pretty much in the same way. And Code Deploy, again, runs a bunch of, takes your artifacts or your containers, whatever you want to call it, and deploys them to your production environments or test environments. In this case, today we're not going to be deploying with Code Deploy because Code Pipeline is already integrated with ECS, and it's very simple to do, and we don't have to work with Code Deploy. Yay! Why would I say we should use this instead of Jenkins, for example? Well, besides the fact that we have to pay Jenkins 24/7 or whatever other build tool you're using, And in AWS, you only pay by the minutes you're using your services. For example, code build, you only pay for the minutes your Docker containers are running. It doesn't really fit in, right? You have your Jenkins instance, which is very long running. It's usually something nobody really touches a lot, and it's static. It's a single point of failure. If you had that happen, you know that no matter how many people you have in the team, a lot of the stuff doesn't get done. You don't deploy to test environments the tester can test, and you can't deploy to production, obviously. It doesn't really go with infrastructure as code, right? So infrastructure as code is extremely powerful, and it allows you to do a bunch of cool things. Even as a developer, you look at the code, you're really awesome with the code, so you know that you can copy paste the line and change two parameters to have your new microservices deployed. Obviously, you want to use stuff like that, and it doesn't really fit with Jenkins because Jenkins is a static tool, more or less. Somebody has to go in and configure the new environment. When we actually deploy our infrastructure, if we use the AWS tools, we can actually deploy the pipelines with them, and we then just have to get pushed into a specific repo, and we're done. All right. So before we go on to debugging, let's look a bit on a few more things in here. Let's look at everything we have between defining our cluster and autoscaling group and the CI/CD pipeline. So everything over here. All right. As we've seen before, we have some default target groups. Don't mind these; they were just there, so it would deploy. You can also specify some static response. I just did it for the sake of the demo. Just included the autoscaling group here. We then export a bunch of, let's say, properties. We put it on the main object where they are public and read only. And I'm going to put say this again. And we then add the default cloud map service. Now this is going to come in handy. Just keep in mind the domain.local over here. And I'll explain it to you in a second when we get to the console. Right now we're using a full programming language, so we can create stuff or not create stuff via conditions. You can do this in CloudFormation as well, but this is much more clean. You can have switch statements, you can create all kinds of stuff programmatically, and basically you're using a full programming language. So you're not really limited. You have endless choices on how you want to structure things and how you might want to have a for each, for example, whatever you want. And we have a property called create repo, and obviously we didn't want to have multiple repos. I just created one single Git repository and added a parameter create repo true or false. And if we go into our demo file here, you can see that I create a repo in the test environment, but not in the production environment. Let's go back to our stack, and we just output the repo URL and auto balance the URL as printed out in the console. And of course, you would receive some sort of output like this, right? So we have a repo URL. Don't worry, it is private. It has a password, so no worries on that. And we have our load balancer URL. Okay. This is our base stack, and this is how we define it. We were basically able to replicate the basic infrastructure in test for our production environment with one line of code. And that isn't powerful, I don't know what is. So let's go on to the front microservice, our front service. And bad with names. All right, so the first thing you'll see over here is that we have a new build pipeline, which takes our Docker repository and our Git repository. Obviously, we'd like to build a Docker container, right? What exactly is getting built? Let me just exit the presentation mode. 1 second and I'll show you. On the left side here, we have the microservices folder, and we have 3 folders: front, service 1, and service 2. And we have a Docker file and an index.php, obviously, because this is about PHP microservices. And we just start from the 7.3 Apache container on Docker Hub, and we add our file. It's not really glamorous, so to speak. And I'll show you in a minute. Actually, I'll show you right now what's in our PHP file. We just have php.info, PHP info, and we have something interesting over here. I don't know if you can spot it. We have service 1, and we have something called get host by name service1.domain.local. If you remember a few minutes ago, we discussed about domain.local, and we were adding it somewhere. What we were adding was the basic infrastructure for DNS service discovery. Right? And obviously, we could do microservice communication through the load balancer itself. You can have your services communicate with each other via the load balancer, but I just wanted to do something different today. And if you're interested in keeping your microservices traffic very, very secure in a private environment, private network, where only those instances are allowed to see the traffic, this is a very good option. It's not the most fancy or featureful, but it is a standard option to use DNS service discovery. And we'll see how that works in a second. All right, if we go back to our microservice definition over here in the presentation mode, we see that we have a build pipeline. Now, build pipeline doesn't really exist in CDK, right? What's a build pipeline? A build pipeline is something that I created for the purposes of this demo. It is a level 3 construct. It's our code, right? So instead of you having 80 lines or 70 lines, something of that sort for each environment, test and production of each microservice, basically having a lot of duplicated code, I created a class which I reuse everywhere I need to. And this is what builds the Docker container. We have a code build pipeline project, which starts from an Ubuntu image with Docker. We basically, let me show you the commands. We log into the private repository. It automatically knows that it's allowed to because it's part of the same infrastructure, and we defined all the permissions it requires. We then take our Git repository and we build what's inside the microservices front folder. This is just an environment variable because we are reusing it, right? So if we hardcode stuff in here, we're not going to be able to reuse it. And afterwards, we push 2 tags. We push the latest tag, and we push basically the git commit tag into our repository. Okay. This is where we push, and we then create a nice little JSON file with the new version to push on someplace else. Okay, these are the environment variables, so that's code build done. We then give permissions to the ECR repository, as we stated earlier, and we create a code pipeline project. All right, we then say that it's gonna start from the git commit. So our source is a git commit, a code commit in this case. And we basically go through the build, and that's pretty much it. What you see right here, I'm going to show you right now in the browser. So these are our pipelines. Disregard this, I was playing a lot before our demo. We're going to have our build over here, and this is what you saw before. We have our source over here, which is our repository. This is actually our add PHP info. This is something that I committed an hour ago. And we added PHP info, that was the previous commit, and then we added our print service one. So very nice that we can see both the message and the git tag, the git hash, which is much more useful than just it's nothing over here. And this is why I like to use a GitHub repository as an entry point for my pipelines. All right, and you can see all the details in code commit. Right, it was downloading, it was adding the PHP file, and then it was pushing. Pretty straightforward. Okay, so this is very nice, and it's reused a few times throughout the code. Okay, let's go back into our front microservice. So defining a CI pipeline, 1, 2, 3, 4, 5 lines. And these lines will pass your linting process because they're much lower than 120 characters. We create a task definition for our Docker file, for our service, basically. This is something more particular to ECS. And then we define our container. We want to use the previously built image. We're going to set it to 520 megabytes of RAM. Honestly, it would do with 128. This is where you specify how much RAM, how much CPU it should consume, the limits, and so forth and so on. And one thing very interesting is that we're using the AWS log driver. So that means that regardless of how many containers we have right now or in the future, every container will have its log centralized in the CloudWatch service for later analysis. We had some port mappings. This is because we're using, you're seeing this host port 80 because we're using not the bridge mode, the AWS VPC mode, which allows us to set up DNS service discovery. And this is our actual service over here. We have a service, which is called front service test. It's in our test cluster. We only want one for now. And we have some options over here for DNS service discovery. We have the name front, right? So we'll find it with front.domain.local, the domain.local part we previously set up. We want a DNS service discovery. We want it to be cached for only 30 seconds. And we have some health checks over here. All right, how does this pertain into the console, you say? Cloud map, let's see how that goes. I'll have a space. Okay. So we have two domain.local. I should have added something in the description to basically specify the test and the production environment to know the difference. You can have different domain names between test and prod, for example, if you want to. You can dynamically create them. I like to have the same stuff for consistency, basically. And you can see over here that we have two services. We have service one, and we have our front service over here. We have a nice little instance, which is healthy. So that's cool. It's very nice. We have DNS service discovery. We have some nice things. You can specify, how many instances you want for the container, like autoscaling. I just set it to 1 right now, but you could put 10 in here and you can scale it on whatever metric you want. Again, CPU, RAM, and also custom metrics. You can define your own application metrics and you can scale on basically whatever is in CloudWatch. For now, we have added a placement strategy, which means that if we have more than one EC2 machine, we usually have these two machines in two, let's say we have 4, right? Two in one availability zone and 2 in another availability zone. And that means that we survive, let's say, a full availability zone crash. And our clients never know that we had a failure in a really big data center somewhere. And obviously, if we have all our containers in just one let's say EC2 instance or in one availability zone. If that goes away, it doesn't matter that we have instances over here if there are no containers over in this healthy availability zone. So that's why we spread across the availability zone. So let's say that we have two container instances for the service. Instead of putting it all in here, we would spread them out across two or multiple availability zones. Again, high availability, always a nice touch. We add some, we basically import some stuff from the base stack, you know, the security group and the listener from our load balancer, and then we add our target groups, right? We add our front-end target group, and we set it with a priority of 100 and a path pattern of slash and, you know, regex, basically everything after slash. And you might say, but if you set this as a full path, how are you going to communicate with the other AWS, with the other microservices? And I would like to have you remember the part where the rules inside the load balancer, inside the listener for the load balancer, because you had a nice little order. And the order is basically in terms of priority. Whatever is lower priority is basically the first on the list. And the rules are evaluated in order. So let's say priority 1, 10, 100, whatever. And if you match on priority 1, everything goes there. Your request goes there. If you match on priority 10, your request goes there. So we usually add this as a priority 100, and you'll notice the other microservices are added with 70, 80. We don't use 1, 2, and 3 because it's best practice to leave a lot of space between the two, just in case you need to add another microservice and you don't want to go through the hassle of modifying the priority on every microservice in your infrastructure. All right, so again, we would have like slash service 1 and this as the last one before the default with slash everything. Okay. We had our test service. Now we have our production service over here. And we basically define it the same way. We add the placement strategy and the autoscale part. All right. Okay. Now, this is something very interesting. Our deploy pipeline, which I commented out to test a few things before our demo, is basically the same thing as our build pipeline. Because I was going to reuse this in multiple services, I wanted to keep my code as clean as possible, and I created a level 3 component to encapsulate all the logic of creating a continuous delivery pipeline. Delivery, not deployment, because we have to approve. And this takes our ECR repository, which is our location where we store the Docker image, our test server service, our test Docker service, and our production Docker service. And we tell it that the name of the container that it's deploying is front-end test definition. Let's look at how this deploy pipeline works. It works in basically the same way as the build pipeline. If you, I haven't spent a lot of time discussing about these import statements up top. All of these imports over here are basically the level 1 and level 2 constructs from the CDK, right? And we are reusing that and building upon that and, you know, abstracting even further. And we have our code pipeline. We have our source action, which in this case is no longer a Git repository. It is ECR Docker repository. We then have a build step, and this build step is required because we have to create a JSON file where we specify exactly the name of the container and what image to deploy. This is basically to link up the ECR and your the Docker repository and your Docker cluster. And this is what we do right here. We parse a JSON and we put it in another format. And then we define the actual actions for the pipeline. We have the build sorry, actually the source, the building of between the source and your cluster, the deployment, and the approval action. And after we define these, we construct it into a single pipeline, and you can see this over here. We have our source, build, test, approval, prod. And I'm going to take you to one right now inside AWS that we deployed code pipeline. Let's take our it failed somewhere. Now, why did you do that? Exceed limit. All right. So if you remember, we have our source over here, which is ECR. We have our build step over here, which we only created our small JSON file over there. We have our test environment, which I'm going to click retry right now. And after we have our test environment, we have our approval. Basically, the pipeline was up until here, and then we have to click something for it to move on into the other environment. So this was all done by this component, which was called like this, right? So a few lines of code and whatever microservice you would want. And this constructs our CD, continuous delivery pipeline. It gets much easier when we take a look at the backend service, and we'll show you how even further we can abstract our infrastructure and get to that state where we don't really have a need for a lot of DevOps engineers working 24/7 to maintain our infrastructure, and where we play with the infrastructure, not play, as we work with infrastructure as it would be our normal code base. And of course, let's move on to our actual services over here. We've taken a look at the front microservice, and I already deployed the first microservice, backend 1 service. I'm just gonna do another deployment for the second microservice, which we haven't deployed yet. I just wanted to do this with you in here in the webinar. So we're gonna let this run. This is gonna run for a little bit. And let's look at the microservice, the backend microservice stack. It's gonna look a lot very similar, and that's for good reason. 70% of the code is shared. And if we would have this in a real project, we would further abstract this into an abstract microservice stack, and we would be reusing it much more cleanly over there. But for the purposes of this demo, I just left it as a separate stack. So we have our build pipeline over here. Of course, we have the ECR repository and the image definition over there. We have ECS task definition. We have our container definition over here. We have our port mappings. We have the EC2 service. Again, not a lot of difference. Where we do have a bit of difference is for the path patterns, right? Because we don't want to have like slash everything. That's the default. That's our front end service. What we're going to do is we're going to add a path pattern beginning with slash and then the name, or in the case, the folder of our microservice, the folder where it's in our source code. So in this case, service 1 or service 2. Again, we want to have a priority which is smaller than the front end, and we can achieve this relatively easily. If we take a look at how we called it, right? We added all the properties in this object, and then we added the folder called service 1 and priority 80, right? You can see priority 80 and 70, they're all lower, so they're gonna get, the requests are gonna get matched and routed before it gets to the actual content service. Okay. So that's the difference. That's a difference. And the rest is relatively the same. Placement strategies, target groups, and the deploy pipeline, of course, that we already saw. All right. So considering we have this whole file over here, we didn't really have to go a lot to do a lot to add a separate microservice, right? If we take a look at what we've done right now, is that we added another folder with a Docker file and service number 2.php. And we basically only did this folder. And let's go to our entry point over here. We only added this. This is all we had to do regarding the infrastructure to add a microservice in PHP. Full with pipelines, definitions, container specifications, high availability specifications. So we only had to do these two things to launch a new microservice. Now think about your day-to-day lives. If you actually be adding a new microservices into your architecture to adding a new shipment provider or whatever, how much time had you actually spent waiting for DevOps engineers or even the more old school version sysops engineers to create something in the cloud or to create something with you in the cloud? What was your cycle time to do that? Obviously, infrastructure as code, or infrastructure is code now, better suits you and enables you to deliver at a higher velocity, right? So everything is done through code, and you can provision whatever you want, whenever you want. And especially when you have high quality components done by AWS and further adapted to your needs by you, you can move much faster. And I like this very much because I have to set up infrastructures for projects quite regularly. That is my day job. So I, of course, like whatever helps me get that done faster, safer, and with a high quality so the clients won't be upset. All right, so I try to deploy stuff and it tells me what it wants to do. It wants to deploy a bunch of services from AWS and permissions. Let's see, these were all the permission changes. I'm gonna say, yeah, I read everything. Obviously, we both know online right now, but they don't know that. Okay, and this is all happening in the background. So let's go into the CloudFormation service and see how this happened. How is this happening? CloudFormation, and we're just gonna keep an eye on ECS. We're just going to keep an eye on ECS for now. So we have two services and test and production. All right, let's go with the stacks. We see that we have a backend 2 service over here and create in progress. Let's see what's going on in here. It's just starting up. This is a demo, so, I'm expecting it to fail. Something always has to go bonkers. But maybe, maybe we're in luck. There we go. So we now have a bunch of things happening. And create complete, create in progress. Whew, lots of stuff. Okay. We're just going to leave it over here, and we're going to quickly go into the next subject, which I'm going to touch upon really quickly. All right, so I've sold you on this offload everything to the cloud and just focus on as little as possible, which differentiates your project from all the others in the world. But what happens when something goes wrong, right? You want to be able to debug. And now I'm going to show you how you can do that using 2 separate things. I'm going to show you how CloudWatch works. And then I'm going to take you on a quest to actually go and get really in the infrastructure and, basically the old school way of debugging. So let's check our logs. First of all, we have a bunch of logs. Don't mind me, I'm just doing a bunch of stuff for webinars and demos and proof of concepts. And you can see that we have a bunch of, let's say, log groups over here. We would also have something like this, front service. And we can actually search for all of this. Let's see. We have all of the logs from the actual container. We can see that Apache 7, Apache 2 or from the Debian image is running our PHP 7.3. And we have, I don't know, we have foreground stuff in here. SIGINT, it's done some stuff on deployment. We can see people actually, we can see the Elastic Load Balancer health check. If your container is failing a health check, it will automatically be removed and another one added in its place. And we can see me that I actually entered over here. Let me just look at the last hour. This is going to be better. We can see. I actually saw before the webinar, I actually saw some automated bots that were trying to security scan this container, right? And we had the classical WP admin, WordPress admin, or all the other stuff that might have security flaws. Wondering if it was in this stack. Let me just filter. No, it was probably in the production stack. All right. So we have our logs, right? Based on our logs, we can do a bunch of stuff. We could use something like Insights, where we could select, let me just select a log group over here, front service, which allows us to use our logs in the same manner as we would use them in Elasticsearch. We can do SQL-like queries and have some visualizations over here. We can have metrics, and we have a bunch of metrics. If we look inside, we were talking about ECS. Let's look at the cluster as a whole. We have CPU utilization, we have memory utilization, and we can graph them, and all these graphs we can put in a dashboard. So that's nice, right? We can have dashboards, alarms. I don't think I have any dashboards right now created. We can have logs and metric. So that's all right. That's a decent way how you can debug things. But what about when you really, really don't know what's going on? What exactly is failing? I want to get down into the actual details, right? You would be inclined to log into those virtual machines. If you're as old as I am, that's what we did years before the cloud, and that's the first thing you'd probably say after looking at some logs. I can't figure out what's going on. Let me just go inside the instances. Now, it's not a good idea to provision SSH keys and manage them by yourself, because people come and go inside your projects. You have to share it with other parties. And it's always a very big pain to rotate the keys and redistribute them, and you're not aware of who has them. If your colleague has maybe handed it to another colleague, it's a mess, right? We don't want to manage that. So how can we use the cloud to better have access to our instances in a secure and auditable way? Let me show you a service called, actually go for here, System Manager. If you remember our code at the beginning in the base stack, where we installed the SSM agent and where we gave it some policies, some permissions, you will be able to understand much better what's going on right now. So let's start an SSM session. Whew, that's a lot of instances. Let's select this one in the test environment. Ma'am, we are now, let's go with bash. We are now inside the instance as root. And this is via your browser. There's no need to distribute any SSH keys. And of course, what's even better is that everything is auditable. So if somebody, removes everything from the server or destroys something, you can find out who it was. In our case, we just want to debug a few things. Obviously, we're looking at the running containers. We have our backend 2 service running over here, and you would be able to do all kinds of stuff. We have root into the machine, and debugging is just as we know it on our local. All right, enough of me talking. Is it still going? Yes, it's still going. No, it's still deploying. Okay. All right. Okay, so it is still deploying. We're going to come back to that and see if it has deployed successfully after the Q&A. Before we start actually answering some questions from Zoom and maybe from other platforms, I want to tell you about two things. First, if you scan this QR code, you're going to end up to a feedback form, and you can click a few buttons to tell us how good the session was. But more importantly, you can write what you're interested in learning about AWS, cloud in general, and what type of webinars would you like to see? Maybe you have an upcoming project using certain technologies, and you'd like to see how you could do it best. There's also going to be a link in the chat room from my colleagues, which are going to take you directly to this feedback form. Now, at the end of the month, we're going to be doing another webinar in this series related to AWS. And we're going to be talking about Python microservices and service meshes. We're going to take it up one step further. We're going to get rid of all the EC2 instances. So we're not going to manage any more clusters. We're going to have a much smaller infrastructure definition, an infrastructure base. And we're going to show you some very interesting stuff on how you can still debug your microservices in that scenario. So without further ado, I'm going to start answering some questions. Santos, will this webinar be available to watch anywhere, i.e. YouTube? Yes, you can view it later on YouTube and Facebook. We're also considering Twitch, if that's, anybody's favorite. All right. Thank you for such an anonymous attendee. Thank you for a great demo. Thank you very much. Let me put it like that. Let's see in the chat section. All right, let me go. Kirill, what are the ways to start PHP server in AWS? FPM, Roadrunner, thank you, especially with serverless. Well, with serverless, you actually use it a bit differently. I'm going to talk about serverless first, and then we're going to move on to other things. In serverless, you basically have a bootstrap script that you define, but you don't have to do that anyway. There's all types of examples and ready-made stuff for you on the internet. If you're interested in learning more about that specifically, let us know, and we'll do a webinar or a blog post about it. You define a bootstrap script which accepts all of the request data that's coming from AWS. You have examples on the internet, and that CLI script accepts this data, and it basically starts your PHP app with those variables. On the other hand, on containers, or you would set it up as we actually did today. We would start from probably a container that you have for all of your microservices, or for all of your something from the community, and you would add your PHP scripts there. You have a bunch of options to choose, Apache, Nginx, and so forth. Yeah, serverless, especially PHP serverless, is quite cool. Especially when you take into account that it is extremely fast to use with MySQL right now, because all of the VPC improvements so far. But I won't get into that because I'm going to bore you. Okay, this is messages from Facebook. The technology is no doubt exceptional and even sexy to use, I would say. But if the infrastructure itself is transported to code based on CDK, there are a few risks where I would like you to comment on. What is the cost gain or loss of writing and maintaining code instead of maintaining it for UI or even JSON? Well, first, it's not really maintaining when you're doing it through the console. I mean, obviously you can maintain it, but it's extremely difficult. Let me put it in this way. Let's say you are in a big project, 20, 40 people, 70 people working for a big client. I work in an outsourcing company, so that's the basis. You could also be in a in a company which has its own products, and you have a bunch of applications or those applications have a bunch of microservices. So you would probably have like let's say 100 stacks or 70 stacks in production, just in production, or maybe in production with test. If you would be maintaining them through the console, I would say that just the console, it would be extremely painful and error prone, right? You can never exactly duplicate what you did a week ago in one environment into the next. So that's no bueno, all right? That's not okay. If you're using CloudFormation type of templates, right? Infrastructure as code templates, JSON or YAML, yeah, that is definitely doable. It's very okay. I would say that the risk is not as, I mean, it's not really different because all this code gets compiled down into CloudFormation anyway. I would just say that caution needs to happen because if you delete your database, obviously you can set it up as that it couldn't be deleted. It just remains there even if you try to delete it. So don't worry about that. But let's say if you were deleting a database, adding it back wouldn't really add the data back, right? Oops, I commented that I deleted that code by mistake. Obviously, best practice and stuff that the CDK also provides is it won't delete your database even if you remove it or your S3 buckets. It will still maintain them. As this is AWS specific, how easy would it be to migrate such an infrastructure to a different cloud provider if cloud cost dictates it? It wouldn't be, right? This is an AWS specific option. And I would like to tackle this question in two ways. One, how would you migrate it? And two, should you migrate? So you have cloud costs, big cloud costs. You can definitely refactor your infrastructure basically to use a better pattern, a better service, or to generally improve it to cost a lot less. There's actually whole types of companies out there that are specifically geared towards that. If this is AWS specific, and you wouldn't be able to do it in Azure with CDK. However, if you would try to have a multi-cloud provider, a multi-cloud experience, I would say that is a very bad thing to want as generally, because you have two cloud providers. You can only really use the lower common denominator from both of them, right? So a lot of the value from the cloud comes from these managed services, from all of this abstraction that they offer. And there's no two things alike, right? There's not one thing that is exactly the same in Azure as in AWS and any other cloud provider. There is the exception of Kubernetes. However, Kubernetes, again, you're not really using the cloud so much, and even certain things in Kubernetes differ from cloud provider to cloud provider. There's a whole bunch of stuff in there, but basically, if you're using just Kubernetes and you're not using any cloud service, you're not really using the cloud to its potential. And that's the second point where I want to get into. Instead of worrying right now about potential something in the future, which you can address through all kinds of means in your current cloud provider, don't, right? Just use whatever you want in the current cloud to the fullest of its abilities. If it has a feature, just use it. Think about it like this. If you would be traveling in a car with an automatic transmission and you come from a standard manual transmission, would you refuse to use it in drive and just use it in the sequential mode and shift up and down every time? Or would you refuse to use the AC if you're your previous car didn't have AC in it just because you might get accustomed to the good stuff. It seems a bit ridiculous. There's a lot of fear, and it has some financial motivation why you should use the cloud to the fullest, regardless of what cloud you're in. Consider how much trouble and how much work and money and time you lose by trying to be cloud agnostic. And now consider your competitors. Your competitors probably aren't doing this, and they can deliver faster and a better quality because you don't have to reinvent, the wheel, and that will take its toll in months and years. So that's my thoughts about this. As the level of abstraction of the solution with CDK right now is rate to infrastructure, it involves cost of development. Is it a lock into AWS technology? Yes, and I don't think that this is a bad thing. Whatever cloud you're in, use it to the fullest, its full potential. And multi-cloud is only for that 1% of companies really big that can afford stuff and really have a use for it, basically. I wouldn't really recommend it to a lot of folks. Okay. I guess that's our questions answered. If there are any other questions we have missed on Facebook or YouTube, we'll take a look after the webinar and we'll respond over there. Thank you very much for joining me this evening. I was your host, Catalin Dumitras, and I welcome you to the future webinar on Python and service meshes inside AWS. Thank you very much and have a wonderful evening. Cheers.